Kia ora team, welcome to lesson 18 of 1.1 mechanics. Today we are looking at kinetic energy and also revising some of the stuff from yesterday about gravitational potential energy. It's going to be a big one, so buckle in. Hopefully by the end of today you can define kinetic energy, calculate kinetic energy using mass and velocity or speed, rearrange that formula, and also, if you are aiming for excellence, discuss how gravitational potential and kinetic energies are related in situations where an object is falling. So, kinetic energy is the energy possessed by any moving object. We know from yesterday that a common example is a roller coaster. So a roller coaster is moving, but it is also off the ground. So all of these times that there is like a hill, that is when gravitational potential energy is being converted into kinetic, and that's why your speed increases going down the hill of a roller coaster. The formula to find kinetic energy is this one here. So energy kinetic with the little k is half times mass times velocity squared. Velocity is also called speed. Hopefully you remember that from the first part. So the faster that an object is going, or the more mass it has, the more kinetic energy it will have. Make sure that you do the squared first, or you put it in brackets, and then you do the times, the multiplications. You can just change this to 0.5 on your calculator, which will make it easier. Okay, just like I said, always remember to do the v squared first, then do the multiplications. That's because of bed mass. Hopefully you know that from maths. So here's an example. Calculate kinetic energy if the man has a mass of 85 kilograms, the bike has a mass of 15 kilograms, and together they are traveling at 10 meters per second. So we're going to do kinetic energy equals half mv squared. That half we've converted into a 0.5 times the total mass. So I've added the mass of the person and the mass of the bike together to get 100. And then I'm going to do my speed 10 squared. So 10 squared is 100. My total mass is also 100, and I'm timesing it by 0.5. And if I do those multiplications on my calculator, I should get 5,000 joules because it's a type of energy. For merit and excellence, and sometimes even for achieved, they can ask you to rearrange the formula. This one is a little bit tricky because it has got that half and it has also got the squared. So these are the steps you need to follow. Remembering that to rearrange a formula, you need to do the same thing to both sides. So here's my original formula for kinetic energy. I'm going to get rid of the half first. So to get rid of the half, we need to multiply both sides by 2. So that leaves me with no half on this side because 2 times 0.5 is 1. I don't need to write the 1. But there's no numbers on this side. So 2 times 1 is 2. So I need to write a 2 there. Then I would like to get rid of the mass because I'm trying to find speed. So to get rid of the mass, we divide both sides by m. So I'm going to divide both sides by m. That gets rid of my m on the right hand side. And then I've got to divide it by m on the left hand side. Then the last step is to get rid of the square. So the opposite of squaring something is to square root something. So I need to square root both sides. Your calculator should have a square root button. So the final formula for velocity is going to be v equals the square root of 2 times kinetic energy divided by m. That is really tricky. They don't ask it a lot. If they do ask it and you do it really well, you can definitely get excellence on that question. So here is an example. Calculate velocity of a 3 kg bowling ball that has 10 joules of kinetic energy. So I put all of my numbers in first. So I've got 10 joules of kinetic energy. My half stays the same. My mass is 3, and I'm looking for velocity. So my first step is to get rid of the half. So I times both sides by 2. So I've got 10 times 2 on the left, which comes to 20. And I've got rid of the half, so I'm just left with 3 times velocity squared. Moving on over here, to get rid of the 3 or the mass, I need to divide both sides by that number. So if I divide this right hand side by 3, I'm left with just v squared. And if I divide this side by 3, I get 6.67. My last step is to do my square root. So square root of 6.67 equals 2.58. I'm left with just velocity on this side. And then I know that my unit for velocity or for speed is meters per second to the -1. Okay, in the very first lesson of this part of the topic, we learned about energy transformations and how energy can't be made or destroyed. It has to be transformed between 2 types. So when an object is moving away from the ground or towards the ground, there is going to be some transformation between kinetic and gravitational potential energies. So if I'm standing at the top of a hill with a ball that's not moving, it's got 0 kinetic energy, and then it will have a certain amount of gravitational potential energy based on its weight and how high above the ground it is. If I release that ball, it's going to start moving. And so as it's moving, that potential energy is going to be transformed into kinetic energy. There will be some air resistance that takes some of that energy away, but you can kind of just ignore that at level 1. So it's moving closer to the ground, so it's losing potential energy, and it's speeding up, so it's gaining kinetic energy. Okay, this is a good excellence example. So this is a roller coaster at a theme park. It's swinging back and forth. So we're going to start up here at this point that it's at now, up in this top right hand corner. So at this point, the boat will stop moving for a moment. So it's reached the highest part of its swing. It's going to stop. Kinetic energy will be 0 joules because it's not moving, but it's also at the highest point that it's going to be from the ground. So gravitational potential energy will be at its highest. So 0 kinetic energy, let's just say, imagine 200 joules of gravitational potential energy. It's going to pause for a moment and then start swinging back this way. And as this boat swings back down, it's going to get closer to the ground, so it will lose gravitational potential energy, and that's going to be converted into kinetic energy. And then when it reaches the bottom, when it's closest to the ground, so it's all the way down here, the majority of that energy, that gravitational potential energy, will have been converted to kinetic energy, and it will just use its momentum to swing back up, and then it will get to a point on this side where it stops moving, and all of the potential energy is being converted back from kinetic. So it's going to be maximum potential energy again and 0 kinetic. And then it will just keep going. Obviously, there will be some friction, like in this part where it's swinging, and also air resistance that will take some of that energy away. That is a very common excellence question, similar to terminal velocity. Okay, there is a video there to watch about the Newton's cradle. If you want to go back and watch that, it's only a minute long. And another common excellence question is when you're asked to combine both of the formula. And I've got an example in a second to show you. So as I just said, because of the law of energy conservation, we can say that at any stage, gravitational potential energy will be equal to kinetic energy. That's because energy in always equals energy out. We're kind of ignoring friction and air resistance. So in some scenarios, we can assume that kinetic energy equals potential energy. And we've got both of the formulas down here. So that would be a half mv squared equals mgh. Here is an example. This is our last slide. So a 43 kg box is dropped out of a plane at 70 meters with no parachute. Calculate the maximum speed it will reach before it hits the ground, ignoring air resistance. So I'm going to calculate my potential energy first because we're starting at the top of its flight. So we know that gravitational potential is mass times gravity times height. So my mass is 43, my gravity is always 10, and my height is 70 meters. So I've got 30,100 joules of potential energy at the top. As it falls, I know that it's going to all be converted into kinetic energy, which is a half mv squared. Remembering we are trying to find the maximum speed or the terminal velocity. So I know that 30,100 joules is going to equal a half mv squared, my kinetic energy at that time at the maximum speed. So I'm going to rearrange this just like we did when we were asked to find velocity. So I'm going to get rid of the half first, times that by 2. So this side will come to 60,200, and I'll just be left with 43, the mass, times velocity squared on this side. I'm going to get rid of my mass next, my 43, so I'm going to divide both sides by 43. That leaves no mass on this side, and on this side it comes to 1400. Then the last thing I need to do is to do my square root to get rid of the squared. So the square root of 1400 comes out at 37.42 for velocity, and I know that the unit for velocity is meters per second. That is definitely an excellent question. If you can do that, you are a superstar. Go and see your teacher if you need an extra explanation. You have got a catch-up lesson now just to kind of process all that information and get those pages done on your daily work plan. Thank you.